Alright, so this is a Facebook I can't pronounce this correctly, but a Facebook poster thingamabobber that shows this problem, and they want us to simplify this expression or evaluate this expression and find out what the exact answer is. Now, I'm going to just do it several different ways, and I'm going to show you how we get with different answers each time. So the first time, I'm just going to go straight through from left to right. So we got 7 plus 7, this is 14, okay? Divided by, and then 14 divided by 7, plus 7 times 7 minus 7. Next thing, this is 2 plus 7 times 7 minus 7. 9 times 7 minus 7. This is 63 minus 7, or we get the answer of 56. This was a very, very common answer. Alright, this is going left to right. We get, we get 56. Alright. Sorry, put my eraser in the spot. Okay. Now let's do this. Let's do about division, addition, multiplication, and subtraction. Division, addition, multiplication, and subtraction. We're going to do this one next. Okay, so we're doing division first. Alright, 7 plus 1 plus 7 times 7 minus 7. That. Addition. 7 plus 1 plus 7. So 7 plus 1 is 8 plus 7 is 15 times 7 minus 7. 15 times 7 is 105 minus 7. Or, this is 98. Okay? Let's try another one. Let's look at multiplication. Sorry, let's look at addition, subtraction, multiplication, and division. So do addition, subtraction, multiplication, and division. Okay? So addition first. 7 plus 7 is 14 divided by 2 plus 7, which is 9 times 7 minus 7. So we did that one. Now we're doing subtraction. So 7 minus 7 is going to be 14 divided by 9 times 0. Okay, then multiplication. So 14 divided by 0. And we know that 14 divided by 0 is undefined. Okay? So basically you can put 0 into 14 forever. Keep going on. It's infinity. You can keep putting 0 into 14 forever. It blows our minds. So we just say it's undefined. We're not going to deal with it. Alright. Undefined. Okay? So you see I did it 3 different ways. And I came up with 3 different answers. Now this is kind of confusing. If we're just doing math for fun, okay, we don't care. But people who do math for fun do tend to care more. And people do math for a living, like your engineer or the guy doing dosage for your medicine. We like to make sure we all get the same answer. It's kind of nice. We kind of like that. To make sure this happened, mathematicians came up with something called the order of operations. Order of operations. Or as I like to say, oops. Okay? Your oops. You have to know your oops when you do math. And this is the basis, really, from which all higher math and later on for algebra. Okay? And so you have to know this, but please excuse my dear Aunt Sally. Parentheses, exponents, multiplication and division left to right, addition and subtraction left to right. Now, you may be saying to yourself, Matt, why this? Why not something else? Why not just left to right? The basic thing is, even though going just left to right seems to be the simplest and the easiest way to do it, The truth is, as mathematicians working with complex problems, especially later on when we get things like variables in there, going left to right really limits our flexibility in solving problems. Doing it this way gives us a lot more flexibility. I'm going to show you what I mean. I spent 10 years working as an engineer designing things like sewer mains and water main systems. Okay, so basically my job was to make sure people don't get things like cholera and dysentery. Okay, important stuff. And so I needed to work on some rather complex equations. And so I want to make sure that I can rearrange this in different ways to make it easier for me to understand it and solve the problem. So in this case, I want to say that 7 plus 7 divided by 7 plus 7 times 7 minus 7. This is kind of wouldn't be the way I would write it. I would write something more along the lines like this. 7 plus 7 over 7 plus 7 times 7 minus 7. Okay? So I want this and this to be equal. I'm going to write it in a different way. Division, for us people who are into math, division is the same thing as multiplying by the reciprocal, by 1 over the number. And addition, subtraction, is the same as adding the inverse. So it also could equal this. 7 plus 7 times 1 over 7 plus 7 times 7 plus negative 7. Now, why do I want to do this? Later on, I'll show you in a second why I will do this. Now this becomes a lot more obvious how to solve it. My first thing is equals 7 plus, we do this first, 7 divided by 7 times 1 over 7. Okay, 7's cancel left with 1, 1. 7 times 7 is 49. And you see right here that why multiplication division left to right? Well, because my division has turned into multiplication. I can show it either as division or as multiplication, so they're really the same thing as far as I'm concerned. So I'm going to do them together, left to right. All right, plus 49 plus a negative 7. I'm now left with addition. Now here comes an interesting thing. However I add these up, I'm always going to get the same answer. 7 plus 1 is, straight up, 8 plus 49 plus negative 7. All right, 8 plus 49 is 57 plus a negative 7, which is 50. Fantastic. Okay? Well, if I add them up, 7 plus 40, 7 plus 49 plus 1 plus negative 7. Okay, well now we get 56 plus 1 plus a negative 7, 57 minus plus a negative 7, or 50. Hey, same answer. What if I were to do something along the lines of, alright, 7 plus negative 7 is 0, 1 plus 49 is 50. Start to get the idea that no matter how I add these things up, they're always going to get the same exact answer. This is why we have something called the commutative and the associative laws of addition in algebra. Because that tells us that in this case, I no longer have to follow my order of operations if I have all addition, because no matter how I add them up, they're going to be the same. And by the way, just like, up here, addition and subtraction are kind of the same thing. I'm going backwards a little bit. Multiplication and division are the same thing for us all, as far as mathematicians are concerned. Addition and subtraction are the same thing. Multiplication and division are really the same thing. We're just kind of showing them in a little bit different ways. That allows more flexibility to solve them, to understand the problem, to evaluate the expression. Now, very quickly, why do we even care? I mean, why do I want to do it in any order? Well, you can quickly see that I see is positive 7 and a negative 7. Why bother adding things up when I know off the bat those are 0? So I'll do these together, that's 0. I'll do these together because 1 plus anything is really easy to figure out. That's 50. Just by looking at the problem, I can solve it a little bit faster than if I were to go straight through the problem. Again, 7 plus negative 7, I know that's 0. 1 plus 49, oh, that's 50. That's easy. It's a lot easier. It saves me actually some mental work instead of going straight through. That's the first reason. The second reason is supposing I'm in algebra, okay? I'm doing algebra. All right, and I replace this with an x. All right, in this situation, I have a little more complex thing. If I were just to add them straight through, all I could do is this. I don't know what x is, so I can't combine it with the other two equations, the other terms in my expression. I'd be stuck with this, 7 plus x plus 42. I'm stuck here because I'm only going to go left to right. I only have to stop at the x and pick up afterwards. But because I know this is all addition, because I know it doesn't matter what order I add things up in, I'm able to combine these two terms, well, they're like terms, and get x plus 49. Okay, so basically this whole idea of understanding the order of operations, when you have to follow them, when you don't have to follow them, allows us great flexibility in order to solve problems and figure out what we're doing.